last time I didn't check the Zoom, so either have the video, have no audio. Although there are people in the Zoom, but they didn't tell me they don't have audio. I was thinking they would have audio, but so this time I checked, the audio is here, so will be available by then. I hope doesn't affect that much. So let's get started without further ado. So just we'll review what we have done and then tell you what we were doing today. So what we will do is to review the things we cover, like the mean, median, and mode, and immediately jump to the remaining summary statistics like range, okay, IQR, variance, standard deviation, coefficient of variation, as a measure of how spread the data is. And then we cover the shape of the data, which give you the skewness and kurtosis, which we will elaborate what they are, which is measuring whether the data is symmetrical of the mean, or they have very fat or thin data shape. And after that, we come to the very last part of this class is we'll be talking about how data are related. Are they positively related or negatively related? Okay. After that, you have time, we'll cover some Excel. I guess we don't have enough time, but anyway, we'll do it on next Wednesday and continue our Excel. Then should be all over for the topic 1. So and then after the topic 1, we don't have assignment yet, but after topic 2, we have assignment. So probably every 2 topic we have assignment. I think in total I have 4 or 5 assignment in total. Okay. So let's review what we have done very quickly. So statistics is divided in 2 parts. Just to remind you that the first half of the course will focus on the descriptive statistics, where you're not deriving new knowledge, rather you're extracting what is inside already in the data. Okay, you're not making any new thing. And the second half of the course will be looking at how you can use the data, if this is representative of what we're going to study, can extend the information from the data to the big thing you want to understand, okay, which is often the case, is more useful, right? But of course, both of them are so closely related, right? So that's why we put them in the same course. We'll remind you the data. There are 4 types of data for our convenience. Of course, if you look at Wikipedia or other textbooks, they have way more classification than we need. At least we know when you look at the mode, will apply to everything, right? But a median doesn't apply to nominal data, right? What's the median of the gender? What's median of the race has no meaning at all. Okay. And for mean, right, doesn't apply to ordinal data, right? Of course, you can always calculate something, but does it make sense? I don't know. Does it make sense, right? A bunch of numbers, right? Just like student ID or credit card number, a number, right? You can calculate mean, median, mode, whatever you like, but what does that mean? It doesn't mean anything, right? It doesn't say stuff, right? But people still think they may be something, right? They think there's something behind, right? Or just people going to buy Mark 6, the lottery, right? They look at what the number in the past that appeared the most, and then that would be more likely. All right, but I mean, those things are pretty much not really making sense anyway. So the graphical representation is always important, but as I said, I don't have time to talk about it in class. You will be doing them in your projects, right? Where you should be showing the graphs to describe your data whenever possible. And then just to recall, this is the 3 types of way to describe your data. Okay, so remember what you're doing here is you get a data from a boss or a client or a customer. You want to analyze it, and the first thing to do is to tell the one you want to talk to a number that summarizes what data is, right? That is where the data central tendency, where the center of data is, right? And as we call, mean is centered by distance, right? Simply speaking, is the mean is where the location, the distance to all the observations on the left, sum of distance, the same as the distance to the right, right? Left and right the same. That's why it's centered by distance. Okay? And the calculation will be just add up divided by n, right? You learn this formula, but you never, well, you are seldom told why, what it is, right? Why adding up divided by n is something meaningful. It's by definition of center of the data by distance, right? And that means that if this measure have to make sense, distance have to make sense, okay? So that's why I said doesn't apply to nominal data, doesn't apply to ordinal data, okay? The next is median. Median is centered by location, okay? You ran the data from smallest to biggest or biggest to smallest, you take the middle guy, right? And when you have odd number of observations, then the middle is obvious. There exactly exists a middle guy. But when you have even number of observations, you don't have exactly the middle guy. You have the middle two guys, right? And the middle two guys, the problem would be if they are numerical data, right? You can calculate mean of these two middle guys. That's no problem, right? The mean makes sense. But when the data is ordinal, then does it make sense still? Not so clear, right? So in that case, you might cite the median would be that two number, right? And also in particular, if this two number are too far away from each other, right? Then the median don't make too much sense, right? Because the data may be divided in two halves, right? One half is very high, one half very low. And you find the median of these two very big, very small number, doesn't make too much sense anyway. So when you have even number of observations, have to be a little bit more careful. Don't blindly apply what you're doing, right? Maybe you are saying I'm very picky about some small thing, but it is actually some small thing that matters, right? Because the big thing is already well known, it's done, right? So why you go to college, right? It's for me to tell you that some small part that you can't easily find on the web, on the AI, right? Why you have to attend class these days, right? It's for me to tell you that some small part thing that you may easily omit, because now why you have to attend, right? Every day, everything is very easily available online, right? So I'm telling you things that you may not notice, right? That's important. Mole is the same idea, but it's more general because you just do counting, right? It's centered by frequency, right? Frequency, how many times appear in data, right? The most frequent one. And of course, you may have more than one mole, right? Because the most frequent data can be many things, many items. So that is also a problem. If a single mole, it's very good, right? If there are multiple mole, then also a problem, right? And also you may also care about not the most frequent one, right? Also the second most frequent one or third most frequent also will be also very meaningful, okay? Sometimes you want to cite the two most frequent data as well, but that would be something you would have to think, right? Because don't never blindly apply the thing that in your practice, right? Because this is something you have to think what they are and then before you apply, right? Because now, as I said, again, AI makes things so easy, right? Then you may just apply the AI solution directly without thinking, right? If you think in this way, then basically you're no different from a high school graduate, right? You have to think a little bit more that differentiate yourself from just a machine that applies stuff. So this person that we'll talk about today and this shape, right? This person is asking ourselves the number or several number we give from the central tendency, are they good? How good they are, right? And also, of course, by looking at how good they are is how spread out the data is, right? The more spread out, the less representative your number they are, right? And of course, this dispersion uncertainty will be a central factor when you talk about the second half of the course, right? Because the dispersion of the data you have, right, determine how good your conjecture from the data, right? If your data is very spread out, right, have a lot of variation, then the conclusion drawn from data would not be that valid. Okay, of course, by increasing the number of sample, you talk to more people, you collect more data, and of course, usually the dispersion will shrink, then make your guess much more accurate. Right? But these two will be we will study these two in great detail for the rest of the semester. Okay. And then we go to the shape. We talk about skewness is how symmetric they are, and kurtosis how thin. But we talk about this probably after the break. So let's go ahead and talk about the 5 measures of dispersion. Okay, first 2 are very similar. The rest of the 3 will be similar as well. So the 2 types. The first 2 is calculating the range. We talk about the range, we're looking at the distance between a biggest number and smallest number, right? Or you look at somewhere in the data, middle, look at the distance. Okay, by looking at distance, it means that you're talking about numerical data. Okay, because when we talk about how data is spread out, you must be talking about distance. So dispersion measure will only be making sense. You talk about numerical data. So everything we talk about dispersion is numerical data. Okay, don't apply dispersion on ordinal data. Okay, it makes very little sense. You can say something, but not that meaningful. Okay, so we talk about the first 2 first, and then the rest of the 3 will be very similar. Okay, the first one is embarrassingly simple. It just look at the biggest number minus the smallest number, and that's it. Okay, why is capturing what we want to capture? Remember, we want to capture how spread data is, right? By picking the biggest and smallest, the simple distance is done, right? So, of course, it's same as the problem we have is if the data outlier, one single outlier, then affect the whole thing, even though the rest of data is very close to each other. Let's see the example. You have the data set 1, 2, 3, 4, 5. The range is the biggest minus smallest, 5 minus 1, 4. And the second example is 1, 2, 3, 4, 50. The difference between the large and smallest is 49. So you can see by simply changing the 5 to 50, you change a lot, right? If you are somewhat typo, making 50 to 500, your range becomes 499. The problem is you don't know the data quality. It might be an error. So by simply doing this, range may not be good enough or may be misleading, right? But of course, if the data is accurate, there's no problem of that. Range is good because it captures what you want to capture, how spread data is, right? But of course, it just take the only 2 number there, so may not be good enough. Okay. Later, talk about variance. We'll take into every single data, but this is only talking about the biggest and smallest. And one way to avoid the trouble of that, right, will be consider a more sophisticated measure, which later we'll define. It's called IQR. Okay, but before that, we have to define what is quartile is. Okay, quartile simply means quart. It's a prefix, means 4. Quarter, right? Quart is 4. Quadrilateral, like 4. Tiles is like a square, right? The tile on the ground, right? Is the square or rectangle. Quartile means you divide the data into 4 equal parts. So like this, right? You have a table 4, right? The data divided into 4 different parts, right? And obviously, you learn the math. If you divide things into 4, like this table, you have to do 3 different cuts. Okay, and the first cut is in the middle. So we learn what is middle is median. Okay, so that means that if you have 3 cuts, the second cut, the middle cut, will be the median. You cut the data here, cut in the middle. That is Q2. If the first half is here, you cut again the middle, that's Q1. And that one you cut in the middle, that's Q3. Okay? Why doing that? Because the range is looking at this end to the other end, right? And the interquartile range is looking at this end to that middle, Q1 and Q3. That is the in IQR. Okay? Looking at the graph to show you the thing is, you look at the data, minimum, maximum. This distance is called range. Okay? And if you cut in the middle, that is Q2. And you look at the first half, cut the middle again, median of first part is Q1. Median of the second part is Q3. This distance is called IQR. The good thing of IQR is it doesn't affect by extreme value, right? It doesn't really matter what these data are, the thing in the middle, right? So this is a very useful measure when you look at how spread data is. Okay. So far so good, I guess. The IQR is very trivial, right? Just like divide them into 4 parts and look at the middle first part, middle second part, the difference between these two middles, right? Nothing should be interesting at all, right? No. There's some complication there. And actually, I think it's the most complicated thing you learn in this class. Turn out to be, if you try to look at this, you look at some software, at least there are 7 different ways to calculate IQR. At least 7. And you may ask, why there's so much crazy thing? The main reason will be the following. Remember, when we calculate median, when there's odd number of observation, no problem, right? There's a middle guy. When even number, the median is in the middle, right? The problem would be, okay, when I calculate the Q1, right, which is the first half of data, what's the first half? The first half, does it include the median or not? And that's a problem, right? Do you include the median? Median data. Okay? So that is a question. So that's why in the high school, depending on which country you're coming from, usually they will have method 1 or method 2, which I'll illustrate, don't worry about that. Method 1 is you do the median, cut it in half, and the median is included in the both half of data, if they are there. Okay? And method 2 is not. I think one is for the US, one for UK. I don't know the French system, or I don't know how things on, but usually this is the 1 or 2 method you will learn in the high school. I don't know which one. Which method you learn? You include the median, so method 1. So what is the one you learn? Method 1, okay. So maybe the US use the different one, okay. But you will see that very different, okay. And if you look at the software, you have to specify which one. So, but let me show you the example, then I'll talk about the one that you will find Excel or Python or R, that is use method 3. Okay. Method 3 is the one that I recommend you to do because it's have better property. Okay. But I will tell you the first 1 and 2 first, and then tell you the third one. So let me have example of 5 observations. Okay. And if we're 1, 2, 3, 4, 5, obviously the median is middle guy 3. Okay. Method 1 will be 3 is included in the data, so it's 1, 2, 3. And 1, 2, 3, the median is just 2. And 3 to 5, the median is 4. So the IQR is 4 minus 2, which is 2. Okay. But why the median is there need not be, right? Because you use method 2. If you use method 2, then the first half is just 1, 2, right? The median will be the average of 1 and 2, which is 1.5. And the median of second half, which is 4 and 5, which is 4.5. So the median IQR is 3. So that means that it does matter the method, right? Looks less simple, right? Just, okay, there's a middle guy with the include or not, so it doesn't change anything. But this shows you they are different. Okay? Of course, you will say, oh, but what happens if you have 1, 2, 3, 4, 5, 6? Yes, in that case, they are the same. Okay, so that's why in the high school they don't emphasize whether this or not. If the data is nice data, it will be fine. But otherwise, it can be like this, right? Because the median is 3.5, right? It's not in the data. So whether method 1 or 2, the same, right? Because in this case, the median is 3.5, and the first half is 1, 2, 3, which is the median is 2. The second half is 4, 5, 6. The median is 5. So 5 minus 2 is 3. Same for the method 2. So these are what you learn in high school. If you can't remember that. Okay. Now I want to show you another one, which is based on the exact definition of what we learned by 1/4 of n+1 rank. What is 1/2 n+1 rank? What is 3/4 of n+1 rank data? Okay. So a definition is coming from this crazy formula. Okay. This formula is ugly, but actually once you understand, it's very trivial. But they write it in the way that it's not easy to understand. Okay. But this is how all the thing looks like. Before you know it, it's very complicated. But once you know it, it becomes very simple. Okay. So what I'm trying to do with this formula will be the following. So it's asking Q1, okay? Maybe Q2 first to be easier, right? Q2 will be half of n+1, right? So maybe I put here, right? Q2, right, is half of n+1. Okay. And suppose your data is n is let me look at the example I have is suppose n is 5. Okay, n is 5. What is this calculation? 5 plus 1 is 6, right? 6 divided by 2 is 3, so it's the third guy, right? So that is how we calculate median, the third guy, right? 1, 2, 3, 4, 5. Okay. And what about Q1? Q1 is 1/4 plus n+1 data, right? 5 plus 1, 6. 6 divided by 4 is 1.5, right? So how to calculate the 1.5 rank data? Okay. Of course, 1.5 means it's halfway between 1 and 2, right? So you can easily do is by average of the first and the second data, right? But actually what we're doing, averaging of 1 and 2, the first and second data, is talking about this. Looking at, pick the first data plus halfway between 1 and 2, right? So x 1.5 is x1 plus halfway between 2 and 1. Right? So this is called linear interpolation, right? Because just like x1 is here, x2 is here. What is x 1.5? Is you start from here, you go halfway between them, the middle guy. Okay? That actually same as the average, right? You simplify this math, it simply is x1 plus x2 over 2, right? It's average anyway. But what in general this can hold for anything, right? If x 1.25, you put 0.25 there. Okay, so that's how this formula is. This formula set is you put the x of the follow-up function, which is integer, right, and plus integer plus 1 minus this times the decimal number. Okay, so this formula still looks not very easy to see. Let me show you an example. You have more abstract idea become concrete. So in this case, Q1, okay, Q1 is a quarter of n plus 1. N is 5. N plus 1 is 6. 6 divided by 4 is 1.5. So 1.5 means that you take the first data, x1, which is 1, and between 1 and 2, which is 1, and 1.5 means we take halfway between 1 and 2, and this gives 1.5. And how to calculate Q3? Q3 is a third quarter of the 6 data, all right? N is 5, n plus 1 is 6. A third quarter of 6 is 4.5. Okay, what is 4.5 data? Is the fourth data plus halfway between the fifth and the fourth data, right? So that's why it's halfway between the fifth and the fourth data. So this gives you 4.5, and this gives you 3. Okay, of course, you may worry about how to execute this, right? Probably only appear once in assignment, and that's it, right? Because why? Because Excel will give you this answer directly. What I want to do is you may ask, why I don't happy with 1 and 2? Because Excel gives you number 3, right? And use Excel. So I have to explain what Excel gives you. Okay, so this Excel to give you this guy, right? Excel will give you this Q1 and Q3 directly. Of course, they will. Later you will see before next week. This is a quantile exclude. This is the way. Excel have two functions, two quantile. One is called quantile include, and one is called quantile exclude. I think this is called quantile exclude, but we'll talk about that. We'll see that. Okay. But this is a way that Excel gives you. Okay. So let's see the other one. So you have n is 6. Okay. You put n plus 1 is 6, sorry, 7. Okay. And Q1 will be 7 over 4. And 7 over 4 is 1.75. Right? So that means that you take x1, right, is the first guy. And 1.75, you take the decimal place, right, 75, right? Maybe I'll write it down for you to see because it looks a little bit tricky. Okay. So Q1 is 1/4 plus n plus 1, which is 6 plus 1 data. Okay. 7 plus 6 plus 1, 7. 7 is 1.75 data. Okay. Okay. Which means that I look at x 1.75. All right. So look at this. X1, X2, 1.75 is somewhere here, right? Means that you take a distance here. You take 75% of that distance will be where you locate, right? So that means that you start from the beginning, X1, and 75% of the distance. Is that okay? So you run, right? You run a third quarter of the distance. So that's, you put it, x1 is 1, right? x2 is 2, and x1 is 1. So this is why we get 1.75. Okay? So don't worry if you don't fully got it because it's in the black thing. I'm not going to ask you in the exam. But you may work it out in assignment to make sure that you know what's going on, but it's not intended for exam, okay? But you should be able to know it because this is how the Excel gives you the quartiles, Now, last time I illustrated Q3. Okay, Q3 is the same, because what Q3 is doing is, instead of 1, you have Q3 is here, right? Let's jump to 3, right? And now, instead of 5.75, you have 5.25. Okay, and 5.25 is just from the 5th. You go by 0.25 here, right? It's 6 minus. That is the way to do it, because the graph is, this is x5 and x6, but you go only from the 5.25, right? So you go only a quarter the distance between them. Okay, and of course this is related to what we call linear interpolation, right? And if you learn geometry, will be looking like this graph in there, right? You jump that, just to a triangle, and this is how much you go up. Looking at this one, interpolation. But I'm not going to talk about math, because our class is the math class. But if you understand, you understand. If you don't, it's okay. Okay, just telling you there's a formula there. So now we want to talk about the box plot, because a box plot is the way to see the data, right? So you see the box plot, for example, this is the range. Because it's minimum, maximum, median, Q1, Q3. Okay, so you can look at this. This is the IQR, this is the range. Same the red one, right? So the box plot is very good, because it visualize the 5 things, and people call this 5-number summary: mean, max, Q1, Q2, Q3. Sometimes they call mean is Q0, the max is Q4. Okay, that is also the terminology when you see the Excel. You can ask what is Q0 and Q5, Q1, Q2, Q3 in Excel, or other software as well. Is that okay? I mean, don't worry about the calculation. As I said, this is, I guess, this most complicated calculation in our class. I probably in the course as well. But as I said, this is in the gray area. You only probably need to worry about for assignment, but after that you can forget about it. Okay, because assignment probably asks you to do it again to make sure you know something, but otherwise it's not something terribly important. But trying to show you that when you say IQR, have to tell us what method you're using, because there are many things means IQR. Okay, now we come to variance. I guess many of you have seen that before. So the question is probably what it is, right? Not the exact calculation. So what is variance? Okay, variance is a measure based on mean, right? Looking at, as I said, right, range and intercolor range doesn't look at every single data, and variance is asking, looking at every single data, how each data is different from mean, the distance from the mean, right? And you look at this, right? It's average distance from the mean, but we square that. Okay, why we square that? Since you have learned it before, right? So why we have to square that thing? Do you have any clue why we square that guy? Why square that? Yes. Yes. If you don't have square, it will be 0, right? Because that's definition of mean, right? So square is the way to take away negative and positive. You add up, that's fine. But that's not the only reason why, because there are many ways to do it, right? You can do not just square. You can do raised to the power 4, raised to the power 6, raised to the power 8. Why you have to add n with squares? For example, the most intuitive is not square. Indeed, the most intuitive is absolute value, right? Which no matter negative, positive, you give you positive, then you're done, right? Indeed, there's a name for this. It's called MAD, mean absolute deviation, right? But why we are preferring variance? Anyone would want to say anything? If you learn M2, then you know. What is different, so different about absolute value? What's so special about that? Anyone learn M2 math? No? M2 math, you learn differentiability is not differentiable at 0, right? There's a kink. Square is like the curve, very smooth. But the absolute value has a kink at 0. What does that mean? It means that the usual calculus doesn't apply. This doesn't have nice property in the math. Okay? So that is the reason why we do the square. Okay? Because once you actually do the math, you do the absolute value version, the calculation will be way more difficult. But of course, it's a nice property. But before we invent calculator, variance is much easier to handle. Okay? But now, of course, not too much. Now we have computer, so that's why people think more about this. But one interesting feature of square is what? Is the further away from mean, because square, it expands much more, right? So that means that if you're far away from the mean, the effect is huge, right? What I mean is you have two data point. If one move a little bit right, the other moves to the left, right? Then actually the variance expand, right? So the data. So what I meant again is like this is the mean. There's data here, there's data here, right? The further data move away from the mean, the other data move close to the mean, the variance will increase. Okay, that is some thing about the square. Okay. Another thing I want to mention is actually variance is just another mean. What mean? When you calculate the square distance, right? Is things to measure. Is calculate the mean of the square distance from the mean, right? I don't know whether you get what I'm saying, but you will see that when we talk about probability in the next 2 weeks. Okay, it's the mean of, so that's why I say the average square distance from mean. It's a mean on the square distance from mean. Okay, and the last thing I want to mention about this is you will notice I have two formulas in this slide. The first line, the first one I have divided by n, and the other is n minus 1. Do you know why we have these two? So which one you learn in the high school? N or n minus 1?
Should be the first.
The first one. So which one you learn? The first one. You always learn the first one, right? Unfortunately, turn out that actually when you use things, when you use it, you should use the second one. Okay. You never use the first one. Maybe rare scenario. Because let me tell you what the difference of them there. Okay. The first one, by no means is the right thing. Is the measure's average distance, right? So that means that if you are government, you have the data of everyone. You want to calculate how spread out data is, use the first one. Done. End of story. Okay. But if you are the firm or you collect the data and you want to calculate the variance, okay? Calculate variance, okay? But you want this variance to be a good guess on what's going on in Hong Kong, then you have to use this one. Let me repeat the statement, okay? If you have all the data, and this data is the thing you know exists, it's the thing study, you don't want to extend your knowledge. That's the end of story. Use divide by n, that's done. No question asked, okay? But if you are studying a sample, which is the thing you want to study, but you can't study everything, you just study some part of it, and you want this to be using for guessing what's going on there, then use this one. This is used to guess what's going on in here. Okay, so that's the idea. Because this is more accurate. My metaphor is like this. This is my usual metaphor. I think everyone would have played basketball or would have seen how basketball being played, right? And for basketball, we have the board there. We have a net here, right? And like this, right? So suppose you are trying to throw a ball there, right? So suppose you are not Stephen Curry, right? If you're Stephen Curry, then you just aim for the net directly. But you're not, right? Then what are you going to do? I'm not good at sport, but people told me, you can correct me if I'm wrong, you're aiming for this rectangle, aiming for this or here, you hope to rebound. Same idea there. You can't use the exact formula to guess. You have to adjust the formula. Okay? And you may ask, okay, wait a minute. Why I have to adjust for the variance, but not for the mean, right? I don't have the mean, I don't have two versions. Yes, the mean has no two versions, but the variance have two versions. Okay? So there are many things you have two versions. And in particular, for variance, you have two versions. Okay? And this version will get better. And don't worry about this, because we will learn this exactly the second half class. In October, I will show you why this is better. There's some reason why that's better. Okay? But I told you this moment because in Excel, you have two functions. One is called variant var.p and var.s. And var.p is the first guy. var.s is the second guy. So that's why I have to introduce to you. Otherwise, you don't know what's going on when you go to Excel. Okay? And let me recall you when to use the first one. If you collect all the data and this data is done, it's over. Suppose you are the president of CHK. You want to know, say, how the GPA spread out in CHK, right? And then use the first one, because I don't care. This is what I care, right? I don't need to extend the CHK knowledge to things outside, right? But if I want to apply this knowledge to, say, I want to, based on CHK data, want to guess what's going on in Hong Kong U, what's going on in UST, then use the second one. Is that clear? Okay, so that is the main idea behind. But you will know, so don't worry about that. This is very important part of the statistics, to differentiate the two. Okay? So you will be dividing smaller. Okay? And you will know why we do that. There's a proof. If you're impatient, you can go to that chapter and see, but at the moment, we are not talking about that. Okay? So here we have some about the variance. Okay? So the calculation is very simple. 1, 2, 3, 4, 5. Okay? And the mean will be 3, right? The first column, it just subtract the first column from the second one. Okay? And you square each thing in the third column, gives you the fourth column. Okay? And the variance is adding up everything in the fourth column divided by number of them, gives you the population variance. You divide it by n-1, give you the sample version. Okay? And some of the students asked me in the other section during the break is, can you find more example to work out? The easiest way is look at the example I give here. You block this, use A4 paper to block it and work out the solution again. If you work out, you're fine with your assignment, you should fine with exam. Because this is the example I giving is just thing I want you to know. I'm going to test you. Okay? So that's, if you're able to do it, you should be fine. Okay? So let me end the section for the break. After I talk about this, it's very quickly. Okay? There's nothing deep here. Standard deviation. What it doing? It take a square root. Okay? And why we need to take a square root? It's a very simple idea. Because of the variance is squared, that means that everything unit become very crazy. Suppose you are measuring the length, which is cm. The variance with a unit of cm square become area, which make no sense, right, in many cases. So that's why we take a square root to make cm square back to cm, right? So everything looks nice, and but actually doesn't really matter, but just let you know. And that's why the name, standard deviation is the standard of measure of deviation, right? Actually, it's called, right? It's deviation measure, right? The standard version of the deviation measure. So that's so standard, right? So that's why everybody use it. And this is standard, okay? And you have the sample version, okay? Sample version is simply n-1, okay? Just divided by n-1, okay? But quickly, maybe I should have a break, okay? I don't want to push a little bit, but because we're falling behind, so let me cut this break a little bit shorter, like 10 minutes break. In the meantime, you can fill in the U reply and tell me how you do it. I'm not counting attendance until the job period is over. Okay, so just for anonymous purpose. So resume at 10:30. So thank you for filling in, because in that way I know whether I need to speed up or slow down, right? So let's see your question. Let's see your result. So the question is why you divide by n-1, not n-2, n-3. The reason, I mean, we'll elaborate later, but simply means if you collect data, you calculate the variance, it is too small. Okay, so that's why you need to adjust by n over n-1 or divide by n-1 to make it bigger, so that the guess will be more accurate. Okay, and later you can, if you want to understand, you can check what you call unbiasedness. That would be the thing we talk about. So that is the idea. But we will talk about that. If you want to check, we actually talk about this in topic 5. Okay, and there we try to tell you that why this is true is because the expectation, which later we'll show, is actually getting a good guess. Okay, and this is a proof behind why we do that. Three slide proof, and explain why with n-1. Okay, if you're curious, you can go ahead to read that, but I mean, I don't think you need to that hurry. But I mean, so that is the reason. And of course, just one of the main idea I can say to you now is, because this is, you are coming from your data set, right? X bar, mean, right? It's not the real one. So that is the reason why, the reason why it did happen. If you know the real this guy, you don't have to worry. Okay? But let's forget about that at the moment. Don't want to confuse you further, because at least for me, I spent several weeks in the library to understand why this is true. Okay, I hope you don't want to spend, but sometimes you have to live with some problem with your life, like this kind of problem. You can't understand every single thing, so have to wait a little bit. Okay, have some patience. Unlike your high school, you may know every single thing, but in here you have something hanging there in your head, keep in your mind, you don't know. Okay, it's very natural. Also, I go back to here. C. May I make groups with students? You mean, I think you mean the projects? Yes, you can. As long as it's in my section, okay? Not the other professor. Okay, I think it's fine, because we're not doing presentation. You just submit your project, so that's fine. Oh, you're tired. Yeah, I think everyone's tired because it's Friday. It's very normal. I taught 8 hours yesterday, so I'm still alive. It's not that bad. I always be happy, so it should be fine. So, okay, to remind you, today is Friday, so be happy. If you are thinking it's Thursday, don't worry, it's happy already. It's Friday, thank God. Okay, this is good, because I used to have someone think it's Sunday, but they said it's windy, maybe rainy in their heart, but that happened. Yeah, standard deviation, yes. New method, okay, IQR, yes. The speed is okay. So far, so good. Mostly say it's okay to follow that lecture. It's a joke, I guess. It's so hard. So I think you mean it's so easy. I'm sorry, it will be harder soon. So let's get back to here. The next one is coefficient variation, which is something very simple, because it just divide the standard deviation by the mean times 100. Okay, and what does it tell us? What is useful? Because you divide it by the mean, it become uniqueness. Okay, because standard deviation is the unit, maybe length is cm, and then the mean is also cm. There's no unit at all. And what it is? Why do we need that, right? Then standard deviation is very standard, then why we need to divide something, right? The main reason is we want to compare across data set of different nature. We want to see whether one data set is more varied, more spread out than the other. For example, suppose in a class we have midterm and final exam. So don't worry, our class don't have midterm, but suppose we have midterm, okay? And midterm, usually the full mark is 50, right? Final, the full mark is 100, right? And by construction, the range, possible range for the midterm is 0 to 50, right? Final is 0 to 100. So variation in the final, usually by expectation, normal will be larger than midterm, right? By the nature of you have more marks to get and more marks to lose, right? So comparing the variance or standard deviation across midterm and final will not be very meaningful because they're different scale. So by divide them by the mean, you rescale it so that you can compare the variation, the coefficient, right? So that's why they call coefficient of variation. Okay? Nothing deep there, but it's useful when you compare across different things, right? Or you compare the coefficient of variation of this section compared to the section taught by other professor, right? Because maybe my full mark is 100, the other professor full mark is 200, right? Or the full mark is 70 or any number. So in order to compare, you divide, and why 100? Usually people 100 is make it a bigger number to compare. Okay, there's nothing special about 100. You can multiply by 1,000, 1 billion. There's make no difference. But the standard is 100. Okay. So now just a simple example that we have 1, 2, 3, 4, 5. The mean is 3. The population variance is 2, and sample 1 is 2.5. We have shown how to do it. And you can do the standard deviation and the coefficient variation, okay, by taking the square root and divide by the mean. Okay, I'm not going line by line. I think it's obvious there. Okay, you can check it out whether you get right or wrong. And don't worry, you're doing assignment on this kind of example. You're working on some data there, so you will be working out by yourself. Okay, you have fun with that. Is that okay? I'm not going line by line. I think this is obvious. Now here comes the next two measure, shape and then they have two measure, skewness and kurtosis. Okay. Let me say the formula is very complicated, okay? But don't worry, you never do the calculation beyond our assignment. Okay. Once the assignment is over, you can throw that away because calculator do all the jobs, right? But I will try to make sure that you work a little bit about your assignment. Okay. First is skewness. Okay. Why I cannot make full screen for some reason. Okay, just bear with that. So skewness, if you look something crazy, but first look at the numerator. Okay, looks familiar. If I forget about the 3, if 2, then you know what it is. 2 is just variance, right? Right? So 3 is what? 3 is a skewness idea. Okay, why? Because negative and positive doesn't cancel out, right? If below the mean, raised to the power 3, still negative, right? Positive, still positive, okay? So if the data have a lot positive, way above the mean, compared to distance to the negative one, so it skew positively, right? So just what I'm trying to say is this, right? That's right here. Suppose this is your data, right? And suppose this is the mean, right? You have some more data here, right? And one data here, right? And filter here, the amount data here, right? But do note that the mean is located such that the distance to the left, same distance to the right, right? But it can be there will be some data here, and there are a bunch of data here, a lot of data here, right? That means that to the left, it's very close to each other. To the right, they're fewer but far away, right? In that case, it's unbalanced, right? It's more that is called positive skew. If you reverse it, it's called negative skew. Okay. In this case, positive skew, which means that the mean is more than median, right? Because the mean is here. The median will be actually on the left, more here, right? The median will be somewhat here, right? If you do the median, for this example, median more somewhere like here, right? So when the mean more than median, in usually, that is what is captured. Okay, and this is usually called a skewness, but we don't use this raw form. Usually, we divide by the standard deviation, raised to the power 3. The reason why we do that because we don't want the unit to be bad, right? Once we divide that, then we're done. Because I also don't want variation change it, right? Because larger variance also affecting this number. So I want to divide by standard deviation so that I just want to capture the skewness, how asymmetric about the data is. So let me show you the graph to give you some idea about skewness. Better idea, I guess. So if it is zero skew, looks like this. Okay? A typical graph, okay? Not always, but typical like this. If positive skew, or like this one. Okay? And negative skew, like this. Okay? So this is the number, right? And we want to say the bigger the number, the more skew, right? So this is trying to capture how skewed data is. Okay? I'll tell the application soon, but before that, I want to give you an ugly formula, very ugly formula, right? If you want to guess the skewness based on data, you have to use this ugly formula. Okay? And don't worry, this is coming from Excel, skew, S-K-E-W, skew. And if you do this, Excel will be skew.p. Okay, we'll talk about that. But this is the formula then. Okay. So, but this formula looks very complicated. It's same as before, but the adjustment factor is like this crazy thing. Okay. But don't worry about that part. Okay. This is just the formula. If you really want to calculate things. Okay. But you always use Python, R, or Excel to do the calculation, right? So, and again, you may ask why we do that. Same idea. This guess is better. Okay. Later you will see the example. Why I would say this is better. Okay. For this example, 1, 2, 3, 4, 5. Without calculation, you should know the skew is 0 because the mean is 3. It's very symmetric around the mean, right? Even though if you don't do any calculation, you know by construction is 0 because the mean is 3. It's symmetric around 3 because 1, 2, 3, 4, 5, right? Symmetric. What symmetric means is where the mean, right? 3. Look at the left and the right. Are they the same? Yeah. 2 and 4 are the same thing, right? Distance from 1. 1 and 5 is 2 away from me. No difference. 0. Okay. So actually you can calculate that, right? 1 to 5, the first column, mean the second column, subtract the first, the second column, give you the third column, square the third column, give the fourth column, raise to the power 3, give the last column. Add them up, the last column, give you 0, everything is 0. Okay. But you can check the calculation by yourself, and I recommend do so because this is the way you will do the assignment. Okay, make sure you understand. If not, schedule appointment with TA and let her show you how to do it. But you should try to do it by yourself first. Okay. And the next one is 1, 2, 3, 4, 10. And by construction, you would guess, I think, is positive skew, right? Because there's a big number there compared to the mean, right? Because the mean is 4, right? So there's 4 here, 10 is a big number far away from that, right? You agree, right? Because 1, 2, 3, 4 is very close to mean, but that's a one observation very big. When you raise to the power of 3, it's very super large. Okay. So the same idea here. First column, the data. Second column, the mean. Third column is you subtract the first column from the second column. And the fourth column is raise the third column by square. And the last column is raise the third column to the cubic, right? And once you add up the last column, you get a number. And you divide by the standard deviation, right? Raise to the power of 3, you get this one. Okay. You do the other way around, you get this guy. Okay. And I would think that this number may be better than this number. Maybe it's larger. It's very skewed. Okay. But you can see the population and sample can be very different. But anyway, as long as more than 0, you already tell us that it's skewed. Okay. It's very skewed. Okay. Of course, I tell you all the calculation. The question is, why care skewness, right? Okay, it's skewed, but does it do anything, right? Why care skewness, right? What's the purpose of this? So, okay, the boss give me data. I tell him the mean, median, mode. He's happy. He asks me how good it is. Okay, I give him the standard deviation, variance, IQR range. Okay, he's happy. Why he has to know skewness? Right? Several reasons. The first reason is in the classical finance theory, we know many of you are taking FIN 3080, right? And we care about mean and variance, right? That's trade-off of the risk and return, right? Expected return and risk, right? We know that there are trade-off, right? If you want an investment have higher return, high expected return, you have to expect it to have higher risk. That is well known in the first class in investment, right? And it turned out that it's not entirely correct. Okay, it turned out that actually we do is we not only care about risk and return, and we care way a lot about kurtosis. Okay, it's a huge upside potential, especially positive kurtosis. It's hugely priced, right? Probably if you pick up a newspaper this morning, you know what's going on now is there's IPO, I think a bicycle IPO, that have oversubscription by 7 or around 7,000 times. Okay, if you check today's newspaper. Why? Why people subscribe something crazily? Because they think they're buying an IPO. There's no, the worst thing is to lose all the investment, become 0. But if happen to go crazy, then you earn a lot, right? So this upside is valued by many people, right? Or why people buy IPO, right? Why people are betting for some crazy stock, right? It's because positive skewed stock have a huge premium, right? Right? Why people invest for the startup? Why people buy Bitcoin? Why people do those? Because Bitcoin and say those kind of stuff can have huge upside potential, right? Why people buy painting, right? Rare painting, right? And many of them makes no money, right? But 1 or 2 particular painting can value a lot, okay? Then that actually has an upside premium. And actually these are all recent 5 years finance research tell us that actually you should include the skewness into valuation equations, okay? but actually the recent finding. And also we learned financial crisis in 2007, and actually the financial crisis in 1997 is due to people forget about the skewness, right? They didn't think about actually there's a huge upside, huge downside, right? If you know the financial crisis in 1997, right? It's because of the people think it's a riskless arbitrage between the bonds in Southeast Asia country, right? Indonesia, that thing, right? But anyway, they forget about the huge risk over there, right? Because they care about the mean and risk and mean and variance. They don't care about those skewness. And why people buy lottery ticket, right? Later you will learn in next chapter, lottery ticket, on average, you're losing money, which we call expected value is negative, right? You expect to lose money, right? You stay in casino for long enough, then you always go broke, regardless of what you do. You stay there long enough. Of course, if you can go, you win, you go, then you win, right? But the reason also lottery because of why? Because a lot of upsides when you buy it. Okay. Although you may not win, but when you win, you can win a lot. Right? On average, you're losing money, but you can win a lot, then you're worth the bet. Right? So that's the reason. And okay, the next question is, okay, now we know skewness is an issue. Okay. And the next question is, why we care about skewness at all is because for the tools we learn in this class, in the second half as well, is when the data is skewed, the standard tool doesn't apply. So you have to correct that skewness. Okay. So that's why when you look at the financial data, you shouldn't look at the price, because price is skew. Why price is skew? Price can be, the minimum is 0, right? You can go below 0, right? So that is a problem. That means that when you try to model it as a bell curve, which we will do for the rest of the semester, it's a problem because you cannot go negative. So you have to, instead of looking at the price, look at change in price, percentage in price. It can be positive and negative. Then everything soft. So that's why we look at the change in price, or what we call stock return, is the thing we look at it. Look at raw price, your problem. Every tools you use will be problematic because it's skewed. Okay? And we look at, say, raw number. Most people doing accounting, right? You know, accounting data, right? Either sometimes negative, positive, there's some issue. We look at financial ratio, you don't have that problem. Okay? And similarly, you look at income growth rather than income. Okay? So there's some way to transform data, but I'm not going to talk about that because of time. Okay. So let me say two things. Again, why we care skewness. First, skewness by itself is into application, like the pricing equation, right? People care about stock that have positive skew. Second is, if data is skewed, the standard tools we are talking about doesn't apply very well. So you have to de-skew it, okay, by say percentage change or some other way, okay? And then you can apply the tool we learned in this class to do it, okay? So there are two things. So that's why your boss will carry a skew, right? Because you have to tell your boss, you shouldn't use the price to do things. You should do return, right? And why? Because skew. If not skew, you don't have problem, right? You figure out your data, even though it's price, it's not skew, so you can use the tools we do, no problem. But otherwise, you have to transform the data in the way that we can do analysis. Okay, I hope that help you to understand what's going on. Okay, and the next one looks not too crazy, because if you look at the 4 here, it become 3, it's just skewness, right? Now become 4 is kurtosis. Okay, of course, some of you are very smart. Say, what about 5, 6, 7, 8, 9, or 10, right? Why stop at 4? Yes, you can do that, but so far 4 is already complicated. Okay, it's already enough for us. Okay, you can go beyond. Okay, but 4 is sufficient for our purpose. And the problem probably is what is 4 doing, right? 3, you know, is capturing the whether they're symmetric or not, right? What's 4 is doing? 4 is doing whether the outlier, right? The data far away from mean, they're actually very far away, right? What I'm saying is because you raise to the power 4, you know the power 4, you make a number huge, right? And you divide it only by the fourth of the standard deviation, right? So if something is very far away from the mean, no matter you're left or the right, this number is huge. Okay. And when, again, why I care about this, when this number is huge, it represents extreme risk, right? So this is actually, kurtosis is a second measure of risk, okay? In addition to variance and standard deviation, is extreme risk, right? So there's a measure if you want to apply to finance. Kurtosis is one way to look at it, okay? And second is kurtosis is used to compare to the magic number 3. Okay? Why there's a magic 3 there? 3 is actually kurtosis as what we know the bell curve, which we learned in the topic 3. And bell curve, by what we learn, is things that appear naturally. Okay, the bell curve is known as normal distribution. By normal, it means everything appears normally. Okay, and why normal? We will learn in topic 4, what we call central limit theorem, which essentially said if things are random and coming from some random process, then it will be bell curve. What I meant is, say, y, IQ, weight, height are all follow the bell curve. The reason is your height is determined by your dad, your mom's genes, how well you're eating, your environment, throughout your life, the many processes affecting are all random. Same as IQ, everything is. And then it means that the math proof is if your measure is based on a bunch of random stuff, it will always have bell curve. Okay, this is a central result in statistics. So if you ask me what is the most important in statistics, it's central limit theorem. That gives you the bell curve. Okay, and that's why also this bell curve, why it's useful, because when you collect sample and everything end up is bell curve. We will learn that in the topic 5. But bell curve is the thing will appear a lot. And the kurtosis of bell curve is 3. Okay, so that's why we would usually care about what we call excess kurtosis. It's -3. If the excess kurtosis is close to 0, we have no problem. Okay, if more than 0, you call the fat, otherwise thin. Okay, and unfortunately, if your data have excess kurtosis, you have to use some special technique which we can't cover in our course. Okay, I think you have to go to stat department to do things. Okay, but it's way beyond what we cover. Okay, and you can see the excess kurtosis have, I don't know, the most ugly formula in this class is like this. I don't know how to explain, but this is the formula. If you want to guess the excess kurtosis of data, this is what you get. Okay, don't worry. Excel gives you directly this one. Excel don't even bother to calculate this guy because this guy is not very useful. Don't even give the population version. The Excel curve is basically give you this guy directly. So don't worry about it. Excel gives the answer. Okay, but your assignment probably asks you to work once. I'm sorry about that, but it's not that crazy. So the data is like this. Okay, you can check 5 data points. And then the first column is the data. Second column is mean. Third column is subtract the first to the second. the fourth column is raise the third column to the square. The last column is raise it to the fourth power. And add last column up, you get the numerator. Fine. And calculate excess kurtosis. Okay. Wait, it's less than 0. That means that this is a thin one. Okay. Compared to the bell curve, this is thinner than bell curve. Okay. And if you look at 1, 2, 3, 4, 5, 15, and you calculate excess kurtosis, population or sample is more than 0. Okay, so they are fatter than the bell curve. Okay, and I'm not going to the calculation. You can check it. I think you would do it in assignment, or if you still have a question, I can go over that step by step next class. But I don't think it's worth the class time to go over. It's very boring to go over that. Okay, but instead, I want to tell you why we care about the tail. Okay, and as I said, why financial crisis happen? It's always, almost always, they forget about the tail risk, right? And you look at the financial crisis 2007, basically they forget about the subprime mortgage risk. But they think it's very safe, right? But turn out to be the extreme risk is gone, right? And you look at insurance, actually they care about a lot of catastrophic risk, right? Because of that's what insurance do, right? And whenever they underestimate it, insurance company just bankrupt, right? And these days, right, this kurtosis is measuring what we call inequality, okay? And because measuring how rich and poor people, kurtosis is one way to do it, okay? Because measuring how different they are. Okay. As also I said, right, kurtosis is measuring risk as well, extreme risk. So that's why you have to check the kurtosis if you want to do investment, right? Because it's not just the mean and variance matter, right? The extreme risk also matter as well. So kurtosis is one way to measure it. Lastly, the last 12 minutes, I want to talk about the last measure. Okay. Next Wednesday, we'll talk about Excel. Okay. So this last measure, okay, is different from what we have said before. Okay. What I said before is the boss gives you data, right? It's a one observation, one feature of the data, right? But now each observation would have 2 features, 2 measures. For example, I look at individual, I have each person income, education, right? Why I talk about that? Because now you are second year or third year student. You may care once you graduate, whether you want to do an MBA, master degree, right? Right? You want to spend 1 or 2 more years in school, or you want to do further study. Well, the question is it worth it, right? Is an extra year or 2 years is going to help. So is it more education bring you more income, right? The very natural question. So is it more of this, more of that, right? Or the other way around, right? Having more education actually make you earn less. It's possible, right? So you want to do it, okay? So how to quantify it is what we call the 2 measure, covariance and correlation coefficient, okay? And by the word covariance should not be surprising. It's variance together. So the formula will be very similar. Okay. And the next one is correlation coefficient. Remember, coefficient is by dividing from something, right? Coefficient variation. So you will see that is variance divided by something. You get this guy. Okay. So the name is very telling. So let me define covariance, which is not that hard. It's very simple. The formula, look at this, is not too crazy. If you forget about the y, you put a square, which is x same as y. This is variance, right? If you forget the y, you put it square, right? Or y and it's x the same, it's the variance. Okay. Now this is a formula, but what this formula is, right? Okay, what does it telling? Okay, first look at this is n-1, the same idea. The sample version is n-1, but the same idea, right? If you want to look at data, you want to guess what's going on, use this one. But this is what we want to do, okay? But what is this formula here? Okay, look at the numerator. It's a product of two items. Okay, the item is xi minus x bar and y minus I bar. You have two number product. You learn from high school. If two number are positive, multiplication give you positive. If both are negative, give you positive as well. If they're same sign, positive. If one positive, one negative, multiply, negative, right? One negative, one positive, negative. So as long as the same sign, positive. Different sign, negative. What does that mean? Let's see a graph. So the data here, x bar, y bar. Remember what x bar is? X bar is looking at the distance, all this distance, same as all this distance. Okay. Distance, y bar is where the distance below, same as above. Okay. So this is a graph. And look at the southwest corner. This observation. This observation is below x bar and below y bar. When they multiply, positive. So every point here is positive. And every point here is also positive because this point is larger than x bar and larger than y bar. So all these points are positive. All these points are positive. And these are negative points. Okay? So you are adding every observation there, right? It means that if there are more observations in this region than this region, you get positive result. If you're more this than that, you get negative, right? So this will be negative, right? Because this point, positive, negative. And that point, negative, positive, right? So that is the idea. So it's just trying to see it's more likely to be on the northeast and southwest than southeast than northwest. Okay, whether in this region or this region. Okay. Okay, so that will be the idea. Okay, that's why I said, is it they above mean the same time, or below mean the same time, or they go other direction? This means they go same direction or different direction, right? The same idea what we want to see, because we want to say what? Is education income go together in the same direction or not, right? So if the covariance of education income positive, then you should do a master degree, right? If they negative, then you shouldn't do it. Very simple, right? So that is what to do. Now, if you're happy with that, we come to the very last measure of this topic. Is called the correlation coefficient. Okay? And don't worry, this is very simple. It's just covariance here in the numerator and denominator are just two standard deviation. Okay? It's the covariance between x and y divided by standard deviation of x and standard deviation of y. Okay? First, do note that this is uniqueness, right? Because x times y maybe cm square, right? And x is cm and y is cm, right? But say in the income and education, maybe x is education, number of year, y will be income, money, then the unit will be money and year, but here's money and year, so cancel out. Okay. And you may ask, okay, why we do this, right? Why have to divide this? Any feature of that? The good thing is this correlation coefficient is always between -1 to 1. Okay. And the good thing is, let me show you the picture. Hopefully I can convince you this is a good measure. So if 1 is on a straight line, okay, and if positive is slightly different from straight line, okay, but it's still going up. And if 0, it means that you can't find a line. It can be here, it can be flat, it can go down, go up, you can't draw a line, then it's 0. And if you can, like a line is here, it's negative, right? And if -1, then it's always a line. So the closer to 1, the stronger relation, right? So you don't need to worry about the data size or what. It's just always from -1 to 1. Okay. Okay. So if 1 is perfect, right? And one interesting thing, if you notice, is I don't show you the sample version because there's no sample version. The sample version is same as population version. Why? Because you divide things n-1, everything cancel out. There's no n there. So this is a very strange case because sample mean or mean and the correlation coefficient, the sample and the population are the same. Very special mean. Doesn't really matter how you measure, the same thing. Okay. So before we end, there's 3 minutes left. So let me convince you. Looking at the example first, and then we'll convince you why we need it. So this data, this y and x. Okay. You can calculate the mean of x is 3, mean of y is 6. You subtract the x from the mean, subtract y from the mean, and you multiply x and this third and the fourth column give you the fifth column. You raise power 2 to the x and the y, and then you do the calculation, the rest. Okay. And because you know how to calculate covariance, you just divide the standard deviation down there. Okay. You can check them out because I don't want to go over the math because it'll be super boring anyway. Okay. So what I want to show you is why we care about this, right? Because if you show, say, marketing, right? If you show their correlation between different products, which means that they're complement, if you like economics, right? Right? If they're negatively related, they're substitutes, right? That's how we define. And then in marketing means that they should sell the product at the same time, right? And there are many things. I'm not going to go into detail, but these are the applications. Okay. Another thing I want to remind you is correlation is not causality, right? Although education may be related to income, but doesn't imply you get study a master, you get higher income. It can be because you can earn a lot, you have money, you go and study master. So it doesn't say anything about causality there. And to establish causality will require much more information than correlation. For example, in the lab, you control X, then lead to Y, then it's causality, right? Suppose I randomly pick some people, study the master degree, and I compare the control group there, then you can do it, right? But the problem is people make decisions and they interrupt this randomness. So causality is not established there. And how to establish causality is a PhD level course, at least master level course. So in undergrad, you never study that. But to go to causality, you would have to go to master degree. Okay. So lastly speaking, I want to mention this, right? And if you learn finance very soon, why we care about correlation? Because if you have a fund portfolio with low correlation between individual investment, the total variance drop. Later you learn this in the second topic 2 and topic 3, about variance. And in this case, right, we want to identify investment opportunity that have low correlation or zero correlation, right? That's why people invest in gold, invest in antique, invest in Bitcoin, because they think they are unrelated to US stock market, right? Why people want to invest in the old days, want to invest in China stock market, right? Because, or Japanese stock market, because it's uncorrelated with the US one. Okay. So I think I should stop here. I'm sorry for 1 minute over time, but that's done the topic 1, the theory part. We'll talk about Excel in the Wednesday. Please make sure your iPad or you have your cell phone able to access to spreadsheet program. Okay, I'll see you on Wednesday.